In this video, we will learn how to use radians to find the length of arcs and the area of sectors and segments. First, let's recall what 1 radian is. If we have a circle with a radius of 4 units, and this angle is 1 radian, this arc will be 4 units long. If we add another angle of 1 radian, this arc will also be 4 units. Adding the 2 arcs together will give us an arc that is 8 units long. The angle subtended by this combined arc is 2 radians. What does this tell us about the length of an arc? It tells us that the length of an arc is the radius of the circle multiplied by the angle subtended by the arc in radians. In this case, the length of the arc is 4 units multiplied by 2 radians, which is equal to 8 units. Let's look at this circle with a radius of 5 units. Inside this circle, there is an angle of 4 radians and an arc formed by the angle. Now, how can we find the length of the arc? The radius is 5 units and the angle subtended by the arc is 4 radians. So the length of the arc is 5 units multiplied by 4 radians, which is equal to 20 units. What about the length of this arc here, which we call the minor arc? We can find the length of any arc by using the formula we learned about earlier. What is the angle subtended by this arc? We know the angle subtended at the center of a circle is 2 pi radians. So this angle is 2 pi minus 4 radians. The length of this arc is therefore the radius, 5 units, multiplied by the angle, 2 pi minus 4 radians. We can simplify this to 10 times pi minus 2, or substitute pi with 3.142 to express the answer as a decimal, 11.4 units. In summary, for an arc that subtends an angle of theta radians in a circle with a radius of r units, the length of the arc is equal to r multiplied by theta. Let's now look at how we can use radians to find the area of a sector in a circle. Remember, the area of a sector is a fraction of the area of the circle, and this fraction is calculated by dividing the subtended angle, theta radians, by the angle at the center of the circle, 2 pi radians. We also know the area of the circle is equal to pi times r squared. Simplifying this expression gives us the formula for calculating the area of a sector, half r squared theta, where theta is in radians. Let's look at this circle with a radius of 4 units. The angle subtended by the sector at O is 2 radians. Substituting these values into the formula for the area of this sector, we get half multiplied by 4 squared multiplied by 2 radians, which is equal to 16 square units. Similarly, we can use this formula to find the area of the other sector in the circle. First, we need to find the angle subtended by the sector at O. This angle is 2 pi minus 2 radians. Using this formula again, the area of this sector is half multiplied by 4 units squared multiplied by 2 pi minus 2. We can simplify this to 16 times pi minus 1. We can either leave the answer in pi or substitute the value of pi and express the answer as a decimal, 34.3 square units. What about the area of segments of a circle? How can we find them, like the area of this minor segment or this major segment? Let's first look at the area of this minor segment. Remember, the area of a minor segment is equal to the area of this minor sector minus the area of this triangle. We also learned that for a sector in a circle with a radius of r units and a subtended angle of theta radians, we can find the area of the sector using the formula half r squared times theta radians, and the area of the triangle using half r squared times sine of the angle theta. So this is the formula we can use to find the area of a minor segment in a circle. Let's look at this circle with a radius of 12 centimeters. We want to find the area of this minor segment, where the area subtended by the segment at O is 1.74 radians. We can find the area of this minor segment using this formula, which is the area of the sector minus the area of the triangle. Remember to set your calculator to radian mode before using it to find the value of sine 1.74. What about the area of this other segment, the major segment in the circle? We can see that it is equal to the area of this major sector plus the area of this triangle. But this time, we need to know whether it's the angle subtended by the major sector at O. Remember, the angle at the center of the circle is 2 pi radians. So this angle is 2 pi minus theta radians. And the area of the sector is given by half radius squared times 2 pi minus theta. Next, we can find the area of this triangle using this formula. Hence, the area of this major segment is given by this formula. We can now use this formula to find the area of any major segment in a circle. Let's go back to our example and find the area of the major segment. Using this formula, the angle subtended by the major segment 1.74 radians and the radius 12 centimeters, we can find the area of the major segment, which is 398 square centimeters. In conclusion, when using radians, we can find the length of arcs, area of sectors and segments using the formulae.